Hello everyone, and welcome to your 8th Apple debugging tutorial. In this tutorial, we're going to be having a little bit of fun trying to reverse engineer a component inside of AppKit. Now, reverse engineering is mostly just a fancy way of saying picking at the implementation details of something that we don't have direct access to the code, and then we're going to try to sort of take those bits of information to derive a larger picture of how that thing behaves. So for example, in AppKit, we don't have any of the source code of how any of the controls actually work, but we can still poke around at different things using the debugger and some other tools to figure out how some of the implementation details of that information, and then from there we can kind of figure out how the whole thing might work. So reverse engineering is just kind of a fun thing to do, is what I'm saying here. So what we're going to be doing in this tutorial is we're going to be looking at a NSSwitch, and we're going to be basically trying to figure out how we could change some of the behavior of that control without actually having access to the public API. Now, why might we want to do some of this? Well, mostly for me, it's just intellectual curiosity to just check out how the underlying structure of something works. And you can sometimes learn a little bit about how, for example, Apple builds some of their objects or how some of their controls. It gives you a little bit of insight as to how you might structure your own things if you think, Apple is doing the right thing. Now, the second thing is maybe you're using a public API and you're hitting some kind of weird, roadblock. So maybe you use a public API and there's some side effect that you don't really expect, and you just want to dig into why that side effect might be occurring. You can use some of the techniques in this video to maybe dig into the implementation and figure out why you might be getting this different side effect that you might not expect. Now, the big caveat that I'm going to put out here is that do not rely on the implementation details that you discover. So it's generally a good idea not to, look at the implementation details, because if Apple, in the next release changes anything about the implementation details and you were relying on something like that, then it, could break your application. So generally, it's just a good idea to stick to the public APIs, and then you'll have a good time. All right, so what we're going to be doing in this tutorial, like I kind of already alluded to, is we're going to be looking at NSSwitch. And this was actually a result of me perusing Stack Overflow, and then I went into the rabbit hole of sort of trying to see how NSSwitch actually behaves. So NSSwitch, if I just go ahead and plop one down here, NSSwitch is pretty simple. It really just has two things. It has an on and an off state. And we really don't have any other control over the NSSwitch through public API. Unlike UISwitch, where you can change tint colors and stuff like that, you really don't have control, at least on 10.15, for any of this behavior. So you can't change the background color or the foreground color. The foreground color is determined by your highlights type or color in the system, and then the background is determined whether you're in dark or light mode. So you don't really have control over the color on NSSwitch. And so we're going to just figure out how we could potentially change the color if we wanted to play around with that today. So that's the goal for this, is we want to be able to change the off color and the on color for NSSwitch. Now, none of this is going to be App Store appropriate to do. It's just a fun thing to look at. So the first thing you want to do always with if you're trying to figure something out, is you want to look at the public documentation of what you actually have access to. So first, you want to make sure that you can't actually change the color if you're trying to do that. And we can see on NSSwitch that it's a subclass of NSControl. There's not really any great way of customizing NSControl directly to give you anything related to color. And NSSwitch doesn't provide any APIs. Now, usually with NSControl, there is a cell backing it that determines how the control is actually drawn. But the documentation explicitly states for NSSwitch that there is no instance of NSCell. And so you cannot override any functionality for the cell. So really, the only thing that we have access to is whatever API is public on NSControl, and then NSSwitch. So that pretty much just leaves us with state. It's about the only thing that you can really change on the switch. And so we're going to try to figure out how we can, break that. So let's go ahead and let's go back to our application here. And I'm going to hold down the Command key and press the View Debugger button. And this will allow me just to kind of inspect the components of NSSwitch. Now, interestingly enough, we learned quite a bit from doing this. So we can see that the NSSwitch is this guy in the back here. And there's 3 subviews on NSSwitch that derive how it is actually drawn. So we have this NSWidgetView class right here, which is a private class that's not available to the public. So we're already off into the weeds a little bit. Then we have another NSWidgetView and another NSWidgetView. So there are 3 of the same classes that are NSWidgetView, presumably subclass of NSView. And we can actually verify that here, but we know that there are 3 subviews essentially that are drawing this NSSwitch. Now, I want to look a little bit deeper into how is this widget view actually drawing itself, and we can learn a little bit about this by just using the debugger to do this. So we can see that there is a layer here, and the layer that I've selected is this background one, so I just hit Command-C to copy that, and I PO'd that plus the layer. And we can see that there's actually content on this layer, and I'll just give you the heads up now that the blue color is actually drawn by the image put into the contents view. So that's an interesting thing to note, because if we want to change the color, we're going to have to get rid of this contents. Another thing that I want to kind of know is, how does the view trigger this drawing? So does it use an update layer? So what I'm going to do is call onceUpdateLayer, and that's not what I want to do. Let's do P, and we can see that we have a value of 1. So the answer of onceUpdateLayer is yes, and that means that this NSView subclass opts into the update layer path, and that update layer is going to be where the drawing occurs for our NSWidgetView. So that's good to know, because now we have a starting point for where some of this content is going to be drawn. Now, before we dive much further, I want to introduce a different tool that we can use to have a better understanding of NSWidgetView. So there is a tool that comes with Xcode, amazingly enough, and it's called OTool. Now, OTool allows you to dive into the Objective-C segments of your different frameworks, and you can basically just dump out the entire class, all the classes that are inside of a framework. So we can say OTool-OV for Objective-C segment and verbose, and then you just pass the framework that you want to inspect. So all the frameworks that are on Mac OS, well, not all the frameworks, but all the system ones are in system library frameworks, and then AppKit is the one we're looking at, and then we just find the current version basically of AppKit in there, and when we run OTool, we'll find out all there is to know about AppKit. The other tool I just want to point out quickly is class-dump, so class dump. And this is a tool that you can download online. It's really great, though, for giving you a human-readable version of what OTool basically does. So just want to mention that, but we're going to use OTool because I don't want you to download anything for this tutorial. But if I go ahead and hit return on that, we basically get this giant dump of everything in AppKit. So now I want to search for NSWidgetView. And we can see here, we've found where the class basically is. So we have right here, you're kind of looking for the ISA to be NSWidgetView, and then you can see the superclass is NSView, and it gives you a list of all the methods. So we have initWithFrame, coder, some other interesting ones. There's that onceUpdates layer. There's the implementation of update layer. We also have some other interesting things. One sort of specific thing is this WidgetDefinition. So there's WidgetDefinition, set WidgetDefinition, and just kind of looking at this, we kind of start to have an idea of maybe how this NSWidgetView is configured, right? Because all 3 of those views, right, sort of that background, the mask, and the knob on NSSwitch are all driven by this NSWidgetView. So somehow it has to be doing something to figure out, how to draw different things. And a likely suspect is this sort of WidgetDefinition. So with all that said, let's go into our debugger again. So we're going to hit continue on the debugger. So we'll be back into our application here. And what I want to do is add a symbolic breakpoint. So we know that update layer for this NSWidgetView is where most of this behavior must be occurring. So we'll have update layer. And if I go back to the application, I'm immediately going to hit our update layer pass because it's trying to draw a new state. So here we have update layer, and we can kind of determine a lot from looking at the disassembly. So here is assembly code that I know I haven't really talked about assembly code, but we don't have to know too much other than sort of how to call methods and what methods look like, that kind of thing. But we might have a different tutorial on that at some point. But this is, as you can see, the update layer implementation. So here we learn a few various things. So the first thing that strikes me is this block invoke. And anytime you see block invoke, that basically means that this is an Objective-C block. So there is some kind of implementation in this block that's hidden from us. But if we want to see it, we can simply make another symbolic breakpoint that matches that. So I copy and paste in that symbolic that method, and we can stop on that when we hit it. Another interesting thing here is that we're coming into widget definition. So we're going to be calling this Objective-C message send here is going to trigger this widget definition call, and then call Q will call that, and then we'll get some kind of result. So it will be interesting to see what the result of widget definition is. We'll come back to that in just a bit. And then there's also this other block invoke call. So if we want to copy that, we will add this new symbolic breakpoint, and that's just something else we can look at. All right, let's go ahead and continue in the debugger to see what else we've got. So now we've hit our first block invoke call. We can see that we're trying to access the layer. So we're doing layer, Objective-C message send, and then we call. And there is this section here which is trying to create or update layer. And what's interesting about this is that it's actually going to call into a particular class to basically have this work out. So what I first want to do is actually just put a breakpoint here, actually right before this call. I'm going to continue to this breakpoint. And what I want to do is find out who is going to get this call. And we can see that if we pass in arg1, that's the person that's going to receive this message. We are sending this to an NSComposite appearance. An NSComposite appearance has sort of these different things in it. It doesn't really matter, but basically NSComposite appearance is a subclass of NSAppearance, and we're starting to get out of the realm of really what I'm trying to address, right? So if we start mucking around with NSAppearance, this could change a lot of different components, right? NSAppearance can change literally every different control that we have in the app. We're getting a little bit out of the space that we're trying to get to. The entire point of this, right, is just to simply try and change the widget view's color on the back of the switch. So this is kind of where I would say, you can kind of keep digging to see, what does the create or update layer do? And you can find that and kind of keep digging to see what different things do from there. But needless to say, we would have to change the appearance, the NSAppearance subclass, this NSComposite appearance thing, to actually get what we want. And that's kind of just going too far beyond what we want to do here. So let's kind of head back a little step here. So I'm going to continue. Here's that block invoke 2, and this is actually another call that tries to get the layer. Looks like it's going to add a mask to this, and it's just a different kind of call, but it looks very similar, right? It's kind of trying to set up this appearance on the layer. So that's all good, but we're going to get rid of those breakpoints for now. So I'm just going to go ahead and disable those, and we'll hit continue. Now we're going to come back to update layer. One other thing that I found interesting was this widget definition. So, we're trying to figure out what actually changes how this NS widget view is drawing itself. So here's a widget definition call, and we can see the call queue is there. And if I want to see what the return value is, I can just put a breakpoint right after that call, and we can print out the return register. So we will PO_RAX, so $RAX. And we can see that there is basically a dictionary that contains a bunch of information that probably is enough information to determine what the type is. So there's a few kind of interesting things, right? There's a value, which probably indicates whether it's on or off. There is this kind of interesting string, which is this widget switch fill. And that sounds like the background of the widget or the NSSwitch itself. So that's kind of an interesting key or interesting value. And we can kind of keep an eye on that. so what I'm going to do is actually disable this breakpoint, or all the breakpoints. I'm going to continue. And what I'm going to do now is hit this. So I'm going to hold the command key down, hit this guy, and now I'm going to switch the switch. And the reason I'm doing this is because I want to see what else I get out of widget definition. So here we're calling widget definition, and the reason I'm doing this is because there are 3 different NSWidget views, so I expect there to be different values if this widget definition is really driving what we're seeing. So here we can actually have a very interesting string, right? We have this widget switch knob. So cool. That means that there is something else happening, right? The knob is changing. We can keep going here. I can hit the C just to continue here. And print out different values. So anyway, you kind of get the idea. We at least have established that there are 2 different types. There's at least knob and fill, and I would expect that there's probably a mask or something else that we haven't hit here. Maybe it's just simply not changing, which would make sense because I wouldn't really expect the mask view to change. All right, so what we want to do now, right, is now that we've established all this information, we know that the widget view has this call of getting the widget definition. So there's a call that we can make to access the widget definition. And then if we can just simply find this switch fill value on the dictionary, we know, hey, we're on the background view of the switch, and we can now try and customize the layer based on that. So that's kind of the lesson in trying to look through different things on the view. One other interesting one that I wanted to actually point out before I go off and change some things is to look at the NSSwitch itself. So if I look at NSSwitch, so here we can see we have NSSwitch, and actually the way that we could really, I'll just try to find a way that we could find this directly. So let's go back to our NSWidget view. So let's say I wanted to figure out, keep finding it here. Okay, so here's the class. Let's say I wanted to figure out where this definition was actually assigned, right? So I could just copy this. We're going to go back to our symbolic breakpoint. We're going to add that in, and let's go ahead and continue. All right, so now we found where set widget definition is called, and the reason I bring this up is because there's this interesting call, which is this NSSwitch updates subviews for state change. And this is where it actually figures out what views needs to change based on the state changing. So it's kind of cool. And this is pretty evident as we look through a lot of the code. We can see that, okay, there's this track view here, and there's a bunch of sort of setting that's done on that. Then there's this knob view, right? These are very distinct calls, and we can probably figure out what each one of these is doing, that it's probably trying to access each one of them and set them up in a various way for doing different things. So that's kind of the general idea here, is that the NSSwitch is updating this NSWidget view, and we just want to customize that now. So there's 2 approaches that we could kind of take, right? We could try and override the track view on NSSwitch, right? Because that's probably the view that is specifically changing the background view on the NSSwitch. The trouble with this is that you have to then make the view behave like an NSWidget view, right? Because we can't make a subclass of a private class. We don't have access to NSWidget view, so I can't just make a subclass of NSWidget view and override some things. I need to make an entirely new class that still can accept the messages of an NSWidget view. So I have to be able to accept a set widget definition, and so it gets a little difficult to try and recreate a class that would do that. But in theory, I could subclass NSSwitch override underscore track view, and then have it basically have the same methods as an NSSwitch view, at least enough for the purposes of doing that. But it's rather dangerous, because if anything is ever called that you don't expect, then your whole program is going to crash. All right, with this, the solution that I'm going to go for is swizzling. So again, not something that you want to do. If you really wanted to make your own slider, you should just make a custom control, and I suggest looking at a third-party thing if you really need to change this color of the switch. But with that said, let's see how we could actually change this. So in application to finish launching, there isn't really a great way to swizzle things in Swift. Compared to Objective-C, you could swizzle things in initialize or load, but those are not available to Swift. So the best I kind of have is to do this all in the earliest time frame. So the earliest thing that I can think of is application will finish launching, and application will finish launching. There we go. And an application will finish launching. I'm going to try and swizzle some methods. So method swizzling is where you can basically change an implementation of a method dynamically, thanks to the magic of Objective-C. So what we're going to try to do is get the implementation of the update layer and change it into my own implementation. So we're going to take the original implementation. I'm going to use the string selector version here because there is no compile time value that I can really pull out here. So we're going to get update layer, and then we're going to have a swizzled version, and I'm just going to call this xxx underscore update layer. And then we want to try and access the class, and then we want to change the method implementation. So we're going to get the widget class first. So because we don't actually have access to the widget class, what we can do is try to get it from using the string. So there's a dynamic way of accessing any class in the running application. You can just say NSClass for string, and it will try and pull out whatever class matches this name. So we'll try and get the class that matches that. Then we'll have our next thing, which is to grab the method. So we're going to say original method, and we're going to do a nice Objective-C runtime call, which is class get instance method, and we want to get the instance method of the widget class, and we want to pull out the original selector. All right, and then the last thing is to get the method that I'm trying to swizzle. So here we're going to have to make a swizzled method. Now what I'm going to do for this is I'm going to make an extension on NSView. So we have access to NSView, right? I don't have access to this NSWidgetView, but NSView is close enough for our purposes. And I'm going to make an Objective-C function that is xxx update layer, and this method is what I'm going to try to swizzle with. So we'll come back to the implementation of that, but we want to get the NSView.class or self, and then I'm going to swizzle with the swizzly method, like so. All right, so now that I've done all that, we can actually exchange the methods. So there's another Objective-C runtime call, exchange implementations, and we just want to swap out the original method for the, and I should call this something else, swizzle method. So we'll swap these implementations. So now at runtime, it's going to literally change the implementations of update layer on our NSWidgetView, and it's going to swap it with my implementation of this xxx underscore update layer. Okay, so now that we've done that, basically we want to figure out how we can update our widget view. So we're going to do a bunch of fun dynamic stuff here. So we want to basically pretend like we are an NSWidget view. And unfortunately, we don't have the methods directly, but there's some other fun Objective-C things that you can do to get all this information. So we're going to do a little guard let here to start us off. And what I'm going to try to get is that dictionary, that widget dictionary, or the widget definition that was defined in that class, right? So if you remember back to here, we had this widget definition method, and I want to try to access that dictionary. So I can do that dynamically by saying self.value for key, and the key is just the method, so widget definition, like that. So now I should be getting a dictionary, and I am assuming that this is a string dictionary and to any object. All right, so with that, we can now start pulling different values out of this dictionary. We're gonna get the widget, so dictionary, dictionary, widget. And if we remember back to what we had here, right, when we were looking at the different states, basically I'm trying to pull different values out of this dictionary that we discovered. So I'm trying to access this widget key so I can get whether we are in the switch fill or not. And so that's one thing that I'm trying to access here is what is that widget. And I assume that the output is a string. And then the other thing is we want to get the value to determine whether it's on or off. So we can say dictionary and I want to access value as an NS number. So this value here is going to be an NS number because it's Objective-C and there's no way to put in standard values into a dictionary, so it's an NS number most likely. Then we have, we want to get the value of that as an integer, so that's that. Okay, so now that we have all the values, if this fails, we will just return. Okay, so now for the fun part, what we've all been waiting for. So if the widget is indeed equal to this string here, we're going to fill that, or we're going to do something based on that information. I get to hit the right key. So we want to get rid of the layer contents. So layer.contents. And the reason we're setting this is because remember that blue color is actually an image in the layer contents. So I want to get rid of that. And then the other thing is if the value is equal to 0, we want a particular color. So it doesn't really matter what it is, but we can just say layer.background color. And we'll say NSColor.red color, actually just red, and CG color. And then if it's not this, else we can use, say, green color. And that is it. So now that we've done all that, we'll go ahead and run it to see what happens. So just bear with me as we do this. We'll see what is the behavior. So interestingly enough, it looks like we almost got the behavior that we wanted. But the problem is, because we swizzled out our update layer, we got rid of all the other behavior, right? And we really wanted to keep the other drawing behavior along with this. So the very important thing that we have to do is, if I want all the existing behavior that was already in the widget class, and then I just want to change whatever, I want to change at the end, we also need to call into update layer. Now, it seems kind of confusing that I've called this same method, but this is actually not what's going to happen, right? Remember, because we exchanged implementations, this call is actually going to call the original update layer. So this calls the original update layer. All right, so now let's go ahead and try this again and see what we get. So ta-da, we have our switch here. And on the off mode, so when value is 0, it is red. And if I click on the toggle, it's green when it is on. So pretty fancy. That's what we can get for some fun swizzling and reverse engineering of the NSSwitch. So anyway, that's some of the fun things that you can do and play around with different things, different frameworks. It's a lot of fun. It's also just kind of interesting to see, a little bit of the details under the hood of how Apple actually implements some of the controls that are there. So with all that said, the last little point I want to make is don't do this, right? This is really bad to put in a real application. Just make your own control or find a different one on GitHub somewhere that somebody's already done the work to make the switch with colors and stuff like that, right? If you really need colors, or just try to use some kind of system default. So anyway, I hope you enjoyed the tutorial, and I'll see you guys next week. If you enjoyed this video, please subscribe to the channel, give this video a like, and share it with your friends. Ways to contribute and additional information are in the description. I'll see you next week.